So you can do it on your own. So especially for night shift too. I really don't want to go that much tonight. So. Third warning is that we'll have a visitor coming in later today, a guy named John Griffin. He is the MasterBrand Production System, or MPS manager for Louisville. So he's coming in to kind of see how we do training here. So see some guy come in the back and see what we're doing here. And look at your friends using it for hours.
I'm here in place of Tabby.
Yep. Did you sign in? Okay. Yep. About told you. All right. I think we're going to get started. Welcome to 8 Ways to 5 Wonders. For those who don't know me, I'm Derek Schneider. I'm the Senior Continuous Improvement Engineer here at Ferdinand. And I'm responsible for all the MPS training. So who can tell me what are some of the 8 forms of waste?
Walking.
Okay.
Waiting.
Okay. Walking, there you go.
Don't it spell downtime? Yes.
Yes, it does.
Delivery.
Okay. Anyone else?
Overproduction, yeah.
Oh, the production.
Defects.
Defects, there you go.
Human potential.
Human potential, there you Guys, those are trick questions. We're written on the board. I'm just seeing if you pay attention to what you read.
Oh,
All
face in there.
All right, folks, sit up front.
Come on, Kathy.
All right, we just got started. Now it's on. All right. So yeah, these are the 8 forms of waste: transport, inventory, motion, waiting, overproduction, overprocessing, defects, and human potential. We're going to go through each of these in detail in the class. Where has this been into? Who's seen the MPS house before? You guys seen it? Okay, this is the MasterBrand Production System house. It's basically a copy of the Toyota production system, but this is MasterBrand's version. So what we have is, we want to have a house without waste, our MasterBrand Production System, where it's changed the way of life, we have change management, and the pillars that support us, one of them includes adding value and waste elimination. That's what we're going to focus on today. Okay? So we're going to go through that. And these are all the foundations you need to have to get there. 5S is one of them. Right? So we're going to talk about value-added and non-value-added actions. Okay? So first of all, we'll give you guys a test. Okay, what I want you to do is count the number of passes the white team makes. I don't care how many passes the black team makes. I just want to see how well you can focus on a task. So count the number of people in white pass, count them up. See how many you can get, how many passes they catch. Okay, any questions? There we go.
Count how many times the players wearing white pass the basketball. How many passes?
Okay, how many passes did you guys count?
15.
15.
Anyone else a number other than 15?
13.
13? 15? Okay. What else did you guys see?
The grill in the middle.
Oh, you saw the what?
In the middle? The grill in the middle.
Do you guys see a grill in the middle of the thing? Who saw a grill? Who didn't see a grill? Was there like a grill in this?
You didn't see it?
The correct answer is 15 passes. But did you see the gorilla? This video is from research by Daniel Simons and Christopher Chabris.
So, who was surprised? Didn't see that grill walk from the middle of the screen.
I didn't.
I didn't see it.
Why do you think you didn't see it?
Because you're focused on the light.
Focus on the white. You weren't looking for anyone in black, right?
No.
So you kind of like just focus. You focus on the white, not the black. So when black goes right through there, you didn't even see a gorilla going in there. They have another one of these where it's a bear, and a bear does a break dance. Same one.
I remember seeing the guy dribble that ball around somebody, but I didn't
You
see
did
it.
that?
I
Okay.
didn't pay attention to who he
So,
dribbled.
so the Japanese have an expression that people are looking without seeing. Is this an example of that? So, I mean, what does it mean looking without seeing?
You're looking at it, but you're not necessarily saying.
Yeah, just like that monkey in the gorilla. You're looking at it, but you're focused on one thing, and you don't, anything you're not focused on, you don't see. That's the way it is with waste. You will walk by it every day and not notice it. But you know, like someone outside your apartment walks in and they go, "What's that over there?" And you're like, "How long's that been there?" And it's got like 3 inches of dust on it. You're like, "It's been there for months." But you walk by it every day and you get used to seeing it, and you don't even notice it. Okay? That's the way it is with waste. So what we're going to do is work on that. So what we want to do is understand the 8 forms of waste, be able to identify waste in process, understand what causes the waste, and I don't say eliminate, but start thinking about how to eliminate it. So, first of all, what is waste?
Anything that you don't need.
Anything you don't need, okay? Anything other than minimum amount, okay? So if we're putting more into it than the bare minimums, it's a waste, okay? It's got to be added, it's got to be absolutely essential to add value to the product. Okay, so once again, these 8, and you're right, they spell downtime. So let's go through them one at a time. Defects. What's a defect?
Anything that like stops the process, that you have to go get a new part or.
Okay. This is probably the easiest of all wastes. When you think about waste, this is probably what you think about. If I walk out there, if I went to a line, how would I spot a defect?
Look for the ugly and the obvious.
Look for the trash hopper with all the parts piled in it. Like, hey, those are defects. They throw them away. Okay, hey, it's pretty easy to spot. If I want to walk out in line, and I want to see how much defects they have. Just look at a scrap hopper. Oh, they're there. Okay, someone's throwing them away. They're defects. What's worse is if the defect gets to the customer and it doesn't get to the scrap hopper. Okay, that's even a worse defect. But you know, at the very best, that part going in the scrap hopper every day. How many dumpsters of wood gets hauled out of here? And how much value does that bring to the company? No, that's probably the easiest one there. Okay. So, what do you see? It scrap in the process. Okay. Let's say you have a cabinet that's missing something. It's missing a component. Missing one of the rubber bumpers. Technically, that's a defect. It's not correct. Okay. So it didn't have to be in the scrap hopper. It can be we ship it out here without something, and that's just as bad. It's a defect. Okay. Or if we have the wrong components used. Hey, the drawer won't slide because we have the wrong rollers in there. Okay. So what causes these? My line's bad. We had over here on assembly where they had the foam was missing off a line, and every time the cabinet came down, it was like putting a nice scratch in it. We just kept making cabinets, until finally said, oh wait, foam fell off. Okay. We didn't maintain our fixtures. Orientation not locked in fixtures, in other words, you can turn it the wrong way to make it that way. Incorrect message components. Overhandling. Why does overhandling cause defects?
Or it's moved around, the more chance you have of
What kinds of
something
dinging
being
it, dropping it, banging it, whatever. Yep. Okay. So how do we eliminate it?
catch before it gets to the point.
Ideally, you catch it before you make it. Okay? I mean, it's better that we throw it away than let it get to a customer, but ideally, we catch it before we make it, or to prevent it from being made in the first place. Okay, so that's called automation or judoka. So, anyone know what that is? Okay. You guys are all probably too young to watch Rocky and Bullwinkle. Growing up, I used to love Rocky and Bullwinkle. They had Peabody and the boy, and then you go back to the Wayback Machine. So we're going to go way back in time to the early 1900s. and a guy in Japan named Toyota, not Toyota with a T, Toyota with a D, who founded the Toyota company, used to make linen. They made sheets and blankets and things like that. And what they did is they had these looms. You think about the looms where you have the bobbin, you slide the bobbin across, and then you bring the handle down, slide the bobbin the other way, and you thread, and you cross weave it. And you know, that's what weavers did. You go to old time villages, you still see people using it. Well, he was a smart guy. He decided, I'm going to hook this up to a steam machine. He's going to throw that bobbin, ding, 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 real fast. I can make stuff faster. But the string would break. But the machine would just keep running. So he'd get the sheet out there, and there'd be a big strip missing out in the middle. Crap, he'd have to throw it away. So he'd run the machine, again, and he found out, yeah, he was 20 times faster running the steam machine than was by someone doing it by hand. Scrap went up about 50 times. So he was actually losing money. So he had this brilliant idea he had the string, and he laid a little lever on the string. So if the string ever broke, the lever would drop, and if the lever dropped, it'd stop the machine. And then the machine would stop, and it wouldn't make a part. You went in there, you fix the thread, turn the machine back on, and keep going. And so you could actually prevent the defects from occurring. Then you had the great idea, so when the lever drops, you put up a flag. That way, you don't have to be sitting there listening to the machine, oh, it stopped. The little flag would, lever, the string would break, the lever would drop, flag would come up. Hey, there's the machine, it's got a broken string. So now instead of having one operator per machine, I could have one operator, 20 machines. You just turned them on, the machines just kept running, and every time the string broke, the arm would drop, flag would come up, and they say, oh, fix that string there. He eliminated ever getting a defect again. Okay? Better product, increased quality, increased productivity. So guess what? Was he stay in the linen business? What did he start selling? Looms. He started selling looms to all the other companies around the world who wanted to make, stuff like this. So that little flag, you know what that flag is called?
Okay.
Andon.
Andon. That's an andon. Now here's what I'm talking about andon. An andon is a flag or a warning or a light that tells you something's gone wrong. When people are talking about andon lights, all that is a light saying, problem here, so you can walk, oh, there's a problem. It's visual control. That's what automation stroke is. And ideally, we set up our lines so that it's just like that loom. As soon as that defect happens, the machine stops. You go over there, fix the problem. And so when we lay out lines, we lay out stuff like this, always try to figure out how to not just detect the defect, but prevent it from ever occurring. That's the best way. All right. And how do you do it? You empower teams to solve. Why would you have teams do it, not an engineer sitting in an office?
They do it every day.
They do it every day. Okay? And the person who knows it every day probably knows that line a lot better than that engineer sitting up in an office trying to do a theory. Okay? So you bring the team in there. So when we do Kaizens, what do? We always bring in teams. That's why. All right, we'll talk about that more later. Okay. Overproduction, the worst kind of waste. Why is overproduction the worst kind of waste?
Takes longer to catch a defect.
Pretty good.
You can create more defects.
Let's say you got your, I'm working over your frame, right? Now, I got the line running good. We're cranking out. I'm going to get out here at 6 today. We're good. We just running these things. We're running up, and all of them done. And they did the very first one down to assembly, and it's cut wrong because the machine broke. Now I've got whole days of production all scrapped, okay? Because I didn't catch it because I overproduced. Okay, I've seen companies do 2-week runs and had every one of them bad because the first one was bad and they didn't catch it. Okay, and they keep building for 2 weeks because they were building in big batches. That's why we try to do just in time. Because if you build that first one and it's bad, you stop. Hey, you build stuff. Okay, so that's why overproduction's bad. So we're giving you an example here of overproduction. I don't think I need to do the video, and see if you can see some of the perils of overproduction.
All right, girls, listen carefully. This is the wrapping department.
Yes, ma'am.
Now, the candy will pass by on this conveyor belt and continue into the next room where the girls will pack it. Now, your job is to take each piece of candy and wrap it in one of these papers and then put it back on the belt. You understand?
Yes, sir. Yes, ma'am.
Let her roll! Let her roll! Wait here. Somebody's asleep at the switch.
here? I thought you were downstairs boxing chocolates. Oh, they kicked me out of there fast. Why? I kept pinching them to see what kind they were. This is the fourth apartment I've been in. Oh, I didn't do so well either.
All right, girls. Now, this is your last chance. If one piece of candy gets past you and into the packing room unwrapped, you're fired.
Listen. Well, this is easier. Yeah, we can handle this okay.
Early example of overproduction. If we're going to assembly, then that's what it feels like sometimes. All right. So how do you spot overproduction? You're walking around the floor right now. How does you spot overproduction?
Excess parts.
Extra work in process. If you go over there and you find something stacked to the ceiling, and there's piles everywhere, and it's like, why is there so much stuff lying around here? You know, I bet if you walk in your apartment, it's one of the things we're looking without seeing. You might walk by and see these stacks of parts all over the place, and I'm like, not notice it. But then you look, why is that there? That's a sign of overproduction. Okay. If you can't swing a cat because it's so crowded, because there's so much stuff there, you go, oh boy, it's crowded. Well, you know what? If it's crowded, it's probably because there's a lot of stuff piled around. That it's a sign that you're overproducing. Excess finished goods. If you go out here to the shipping dock, and you can't walk through there because the boxes are piled halfway up the assembly line. Maybe we're building faster than they're hauling away. Okay. So what's the cause of it? Unbalanced workloads. What does that mean?
Like you're making it faster than your customer can.
So like a finished department can make it like half the time that assembly can take it. So they just keep building up, because they aren't balanced. They aren't a good, steady, even flow where I can do an 8 hours, but you can do an 8 hours. Unreliable equipment. Okay. In other words, something breaks down, and the assembly line goes down, and frames just keep chunking away. Okay. Just in case logic.
Need it just in case.
You know what? I know where something's going to screw up. This line goes down all the time. We're running good today, so let's just run the dickens out of it, stack it to the ceiling, so that way, just in case something goes wrong. Or you go. I was actually doing a 5S event, and they had printer cartridges. So we opened up a cabinet, and it had probably 50 printer cartridges in there. Why do you have so many printer cartridges? Well, just in case we run out and there's none in the storeroom, I want to make sure it happens. 50? About 2-3 weeks. You have a year's worth of stuff here, you know? It's like a 2-year supply of printer cartridges, just in case. People love that just in case thing, okay? long process at times. In other words, if it takes me a long time to do changeovers, what I'll do is, rather than short time changeovers, I have to build a bunch of stuff over to carry me while we're doing the changeover. What's the real problem? It's taking too long to change over. Okay. How do you get rid of it? Continuous flow. Once again, I make one piece, you make one piece. I make one piece, you make one piece. Make it into a pull system, so that you only fill a cart when somebody pulls a cart. Like a spot on the floor, and it's like when that spot's full, you don't build anymore. When it's empty, you build it. That's continuous flow. Okay. Don't use batch processing. I went down to GP2, our Mexican plant. They're one of our suppliers for DAs, and they have a warehouse there where they keep 2 weeks inventory. And what they do is they do batch processing. They'll do like a week supply and then put it in the warehouse, and then do one changeover, do a week supply. But like I said, if any one of those are bad, that whole warehouse is bad. So we're trying to get them to change, and they're just, all right. Waiting. Why is waiting a waste?
Not producing anything.
We're paying you to sit on your butt, okay? We're paying good money, and you aren't making any profit. That's kind of a big waste. Okay? So, idle time between cells. If one's running faster than the other, or I can't, so I'm waiting for them to finish their parts. I'm down here assembly. I'm waiting for this cart. I'm waiting. Okay. How do you spot it? If you see machines that should be running that are just sitting there, if you see operators, okay. I ran a plant up in Michigan, and the vice president of the company came down to visit me. He walked me around, and he actually taught me something. Is that he goes, walk with me here and count hands. See how many you see your hands that you can count, or how many hands are touching something. Okay? If you're touching a part, you're touching controls, you're touching something, count those up. And see how many hands are touching something, and how many hands are just not touching anything. If more than 50% of the hands you count are not touching something, your people are waiting. If less than 50% are, then your people are fully employed. Because you're going to have times you don't get in your hands. About half the time, someone should be on their hands. I've walked around here, and most of the lines, we're running about 60, 70%. We're doing pretty good. But I've been in some places where you walk in there, and 70% of people are doing this, doing this, doing this, okay? You ain't working. You're standing there like this. I mean, that's a great sign. I'm waiting. Okay? My production flow isn't keeping me busy. There's something wrong. I'm paying this guy to sit around. You know what? People really don't want to stand here. They probably want to do something busy. Okay? Waiting for information in another department. That to me is the worst. Because it takes me a while to move that cabinet from here, or that part from here, this department to that. That takes some time. How long does it take to relay that information? Like, I don't know what to run next. I have all these parts, I don't know which one to run next. How long should that take you?
2 seconds.
About 2 seconds? Yeah, you people waiting around. I don't know what to run next, man. I'll wait for someone to come tell me. Okay, that's the easiest one to fix. Okay, so that to me is like the worst. So what causes this? Unbalanced processes. Once again, one department runs faster than the other. Long changeovers. Things break down. Okay, batch building is the enemy. That's like the Mexican plant. I'm running a 1 to 2 week supply of this part, and then I'll do a changeover to 1 to 2 week supply. When I went down there, they have this great computer screen that tracks every order through there, every work order, and its status. And if it's late, it's red. If it's late, like a DMR, it's red with a machine inside. But if it's really, really, really late, it's blue. I'm like, dude, you got late, very late, and very, very late. I go, don't you think you have like just too much late? Why don't you start getting this stuff done? So like one of the things I did is I told them to get blue traffic cones, because they'd have 200 pallets. I went there and I said, which one's, this one's blue, ready to run, should be the next one in line, where is it? Took 20 minutes to find it. I said, guys, you're taking blue traffic cone, and if it's blue, which is not the very, very, very late ones, put a blue traffic cone on, so you grab those first. Well, they don't want to do that because that'll mean changeovers, and they like to do everything in batch. Well, we're not running that color now, so we'll just set that one aside until we run that color again. And that might be a week or two. And that part's in later and later and later. Because they love that batch processing. All right? That's one of my problems. Okay, so sorry, I got glare here. Way to eliminate it is, you ever know what takt time is? That's how often the customer orders it. So what you want to do is you want to do a Kazumi chart where it tracks your production against the takt time. Keep your machines running. Machines don't break down. You don't have overproduction or waiting problems. Okay, so that's why we do TPM. Okay, standardized work. What's standardized work? That's a whole other class I teach. What's standardized work?
The same way every time.
Okay, it's actually more than that. It's like an SOS on steroids. Because an SOS tells you how to do something. Standardized work is the best way possible with SOS. I could have a lot of waiting time in my SOS. Hey, go sit there, wait 20 minutes, wait for a part. It's written down, I'm doing what I'm told, but that's not right. Standardized work would eliminate that waste and then write the SOS, be more efficient. So it's like it's an SOS on steroids. My favorite, not utilizing people. What's this?
So if you have something that needs done, but you have someone over here waiting for a part, utilize them, then another process.
Okay, that's utilizing the people and their skills, but really it's using their what?
Their knowledge.
That's why you're in the class here today, guys. Okay, we're here to make you guys smart, to use your potential, to train you guys. If you have a problem, I've been in plants where the only people who could fix a problem was the engineers. I have an engineer in an office like, hey, we're making nothing but scrap. So everyone would sit there, everyone would go into that wait mode, and that engineer would wander down there and he'd like, oh, you're out of this. Refill that can of paint. So then they'd walk over and they did. They knew. They totally knew they were out of paint. That was not in my mind. But you know what? That's the expert's job. They don't pay me for that. Okay? Basically is that you're not utilizing your people skills. Okay? The more you utilize the people on the line who are doing the job, the better you'll be. Okay? If you come up with hey, I got a great idea. Let's do this, and you have to like force it down their throat, it probably means you didn't ask them first because they may not want to do it that way, and they may have a better idea. Okay? If you have to force someone to make a change, take a look where that change is not right. Okay? And here's the very worst one. Hey guys, why don't you run the line this way? This will work really good. Okay, we'll do it your way. All right. Because what's the opposite of love? And it's not hate. Come on, you guys are all married, got girlfriends, boyfriends, whatever. You know what's the opposite? It's not when your spouse or your partner says, I hate you. It's when they despise you. They don't care anymore. Apathy. You know what? I really don't care. And that's the worst. Okay? In a relationship, when the partner just no longer cares, what happens? You know what? I've just given up on this a long time ago. In work, when you know what? We're making nothing but scrap. I really don't care. That's the worst. Okay? And how do people get from that love in a relationship and love their job to that I don't care anymore? So they've been abused and they're not listened to. Okay? Just like you listen to your spouse, okay, I gotta tell you, wife was really mad at me today. She said, we needed to talk. Okay, that meant I listened for an hour and didn't say a word while she talked. At the end, she gave me a big hug because that's the best talk we've had in years. I didn't say a word. I just listened, okay? Listen to your workers, and they'll give you the suggestions for improvement, okay? Ask them what's wrong. Walk them in. What's wrong with this line? Well, usually this. They deal with it every day, okay? So, root causes, encourage wrong type of behavior. Get your numbers out. I don't want to listen to you. I don't pay you to think. Just work. Okay? So how do we fix it? Have people take ownership of their line. Okay? General Motors starts like $27 an hour. Okay? Great benefits. Okay? Toyota, I think, starts $16 an hour. Benefits are okay. But if I go outside a GM plant, everyone walks outside, and it doesn't say GM on the back of their jacket. What does it say? UAW. Their loyalty is not to that company. Their loyalty is that union. If I go to Toyota and walk outside that plant, what's written on the back of their plant, on their jacket?
Toyota.
Toyota. Okay? Toyota's voted down every union every time it's come up for a vote. There's not a unionized Toyota plant anywhere in the world. Okay? The people love their job. Have you ever worked at the same Toyota plant? No one's ever standing still. They are always busy. When break time comes, you're like, break time, then back to work. But they love their job. Why? They own that job. Okay? If you're running a line and you drop a screw, like, oh my God, drop a screw, the whole factory will stop. This motor's starts here, and crosses this line. And you start working on it. If you're not done by the time it hits this line over here, the line stops. And every day, it's all one line. Entire factory, 3,000 people, stop, take a step back, and do this, and wait. When the ambulance are going on, you missed your tack time. Engineers will come in there and go, what happened? I dropped a screw. How do we fix it? Well, if I had a magnetic tip on this. All right. Magnetic tip, listen to your ideas. And say, okay, well, Kaizen afterwards, how do we fix this and how do we make this throughout the plant? And guess what? The person who dropped that, they own it. It's theirs. They lay out this line, how do you do it? And the engineer who works for them and says, how do we make your job better? How do we make you faster? Okay. So you got to hit that tack time. And then when you don't, everyone from the president of the company down knows someone missed their tack time. Yeah. But they own that process. And you know what? When people use their brain, it's a lot better. My theory in life is I treat everyone as if they're brilliant. I never talk to anyone like they're stupid. I always talk to them like they're the smartest person in the world. And you know what? There's a hell of a lot of smart people out there. But a lot of people don't want to say it. Get those involved. Why do you think we, in Kaizen, why do you think we bring everybody in? Okay, especially the people who work on it. Okay, transportation. This is like carrying it with a fork truck or a truck or something like that. Why is that a waste?
Adding value.
If you're a customer, are you going to pay us because we drive from the hilltop down?
No.
If you go by a pizza place, aren't you paying them more money because they're ovens like the next building over and they got to put in a car and drive it over? They're going to charge you twice for that pizza because I got to drive the car over. Oh yeah, you drove it further? I'm paying more for that pizza. Are you going to find the guys who's like, no, I'm going to charge you more for pizza? The customer ain't paying for it. They're going to pay you to drive things around. Okay? Anytime you pick up a moving part, by definition, you're wasting money. It doesn't have value. The Japanese have a word for conveyors called moving warehouses. Because if you have a 100-foot conveyor or a 10-foot conveyor, the customer ain't paying you anymore. But a 100-foot conveyor will break down more often and have more maintenance, be more expensive than a 10-foot conveyor. And if you ever rubberized a belt or vulcanized a belt, that's expensive. It takes a lot of time. All right, so we're going to talk about transportation. Okay? In the 1980s, Mercury Marine was losing money. You ever seen Mercury Marine and Mercury Outboard Motors? Okay. So what they decided to do is they said, look, the problem is our labor costs are too high. Okay, we're going to have to not pay our people as much. We're going to have to lay off a whole bunch of people, and really, we can't compete with the Mexican labor costs because we just pay too much. So we're going to shut down all our plants and move to Mexico so we can pay people less. But before they did like a value stream map, and they took one part. That's this housing piece right back here, this little piece right there. They took that and they filmed it from the very start to the very end, and they just followed with a camera all the way down and film this. Okay? So we're going to see if the real problem is that they pay their workers too much. Okay? So you watch this video and you tell me whether you think that's the real problem.
The sequence that follows traces the production flow of an outboard drive shaft housing from raw material through assembly, or as we say, from the aluminum ingot to the shipping box. The process begins with shifts. The crushed and dried and melted. And then we move it, alloy it, move it, charge it. The die is set up, and after the first piece is qualified, we test it, move it, inspect it, move it again, count it, identify the container, store it, pick it, move it again, trim, move, sand, move, shot glass, move, inspect again, tag, move, count, make out a shipper, load the truck, ship to the machine plant, unload, move, count it again, receive it, take it, it's put in storage. Then we pick it, move it, and set up. Inspect the first piece, qualify the setup, machine, gauge, wash, move, stage, move, patch, sand, pack, move it again, brush it, and move it. Hand sand, move. Then, final inspection. Then we move and again count. We create a shipper, a ticket, ship it across the aisle, receive at assembly, recount, determine the order status, identify the container, decide where to put it, then put it there. When we need it, we pick it, prepare move instructions, tag container, move, complete the transaction, stage, load iridite machine, iridite treatment, unload, 24-hour cure, paint line stage, move, hang, blow off, auto pre-prime, manual pre-prime, unload, move, load, stop and drop, transfer, move, stage, move to assembly line, assemble, load paint line, mask, blow off, mask, auto prime, manual prime, auto finish, manual finish, demask, unload paint line, load transfer line, transfer, unload, and finally assemble, then transfer, run in, test, unload test line, load transfer line, wash, wipe, touch up, transfer, unload, finish assemble, box, move, stage, ship. Let's summarize what we just saw. There were 122 individual steps required to produce the housing, but only 27 of those were direct production steps, such as casting, trimming, drilling, and painting. The remaining steps were done to check our fellow employees' work or to move the part from plant to plant, a distance of nearly 4 miles. The housing was in our various plants, a total of nearly 1,500 hours, and 106 different employees came in contact with it. What we just saw.
Okay. Do those numbers up there for a minute. So was their problem was that they're paying their people too much?
No.
How many times did they move?
More than every day.
Talking about transportation not being valued?
Yeah.
I don't know, I've seen this enough times, but there's one of them where they have it here, and the lady, first of all, it's 1980s, so the computers are big and the hair is big. Ignore that. But the lady's on the computer, and she makes a shipper. And so they count it, they do quality checks, they put it in a box. She makes a shipper. They ship it 10 feet across the aisle. They had an inspector there who took every part out, inspected, counted. They just did it there, but they had to make sure they did it right. Inspected, counted. Then they had a woman prepare a storage location, and they picked it up and they put it in a storage location. Now she had to give assembly to a ticket to the forklift driver, so he knew where to put it. Then when they needed it, then they went and got it, brought it back down, checked it again. Okay, that was like 3 or 4 steps there where it moved 10 feet and was checked 3 times. So, what was their real problem?
Transportation.
Was it? Okay. When you had only 27 parts were actually production parts, and almost 100 steps didn't help it, didn't build the product at all. You were moving it and storing it. painting, okay? 106 people didn't touch. Was the problem we paid these 106 people too much?
No.
Well, the fact is we had all the other crap in there. So what they did is they actually streamlined their process, and they still buy Mercury Marines made in America. But they put this video together to show you the impact of transportation. So it's an old video, but I really like it. So actually what I'm going to do is grab that camera right there and have George and I take one part and go right from the hilltop to the south warehouse, the landing zone, and like follow one part all the way through here up the cabinet and see if we can do the same type of thing with this. Okay. So basically, whenever you're transporting from one area to the other, any of the transportation, you have to do it. But you don't get paid more if it's longer. Okay. Once again, batches, shipping from one factory to the other. Okay. A lot of that's overproduction. It's distance between areas, and then silo effect. What's a silo effect? That's when I'm worried about my lane. I'm worried about my department. Hey, we're running good. We're going to run these numbers. You know, just like that overproduction, and that we're going to build it so much that there's nowhere to put it. So we'll up in places where we built so much we couldn't store on the floor. So we went into a warehouse. We shipped it 10 miles away to a warehouse because one line was running so good we didn't want to slow it down. And we shipped it to a warehouse 10 miles away, and we needed it. We brought it back. Wow, that was pretty dumb. All right. So how do we do it? Lay out your plants. You don't have to drive it so far. Okay. Create flow with the customer pulls. In other words, you don't build it until the customer needs it. Okay. I don't got to find places to put it. Utilize value stream mapping. That's a whole other class in itself. That's where you take the plant, not just, you don't look at one department. You look at that part from the time it enters the door in the plant all the way through, and all the wait times, all the waste times, all the transportation times. You look at that whole, basically what that video was, the whole production line, and you try to eliminate the waste out of that. That's value stream mapping. That's a whole other class you're welcome to take here later. Inventory. Okay. Why is inventory bad? Money tied up, you ain't doing anything with it. It's kind of like buying 50 printer cartridges, just in case. It's like my wife. She doesn't go to Sam's Club, so she came back and she had like 10 cartons of milk. She goes, "Look how much money I saved you," And she goes, "They had them, you buy 4, you get 1 free, so I bought 10. So look at how much money I saved us." Like, you didn't save me a penny, It's, and actually, so I found out if you actually take milk, you put it in a crock pot, you get one of those yogurts. You grab a yogurt and it says activated stuff in it. You put it in there and heat it up in a crock pot. That whole thing will turn to yogurt. Just like that's when you have 10 gallons of milk. How to use it up. All right. So then she comes back the next time and she's got like 6 cases of baked beans. They're on sale, so I bought a whole bunch. Look how much money I saved us. Okay, that's like a 2 to 3 year supply of baked beans. I don't like baked beans, Okay, so they're going to sit there forever. And in the meantime, I already paid for them. Okay, so that money's out of my pocket now. So all the savings is gone. And think about companies. Companies are kind of like a, let's say that you don't have any money in the bank account, but you have a high interest credit card. You put everything on a credit card. But you got high interest payments. But guess what? I'm not paying for it because I got a credit card, right? Companies don't carry cash in the bank account. When they buy markers, when they buy what DA is coming in, when they buy all this raw material wood, they don't write it with a check. They take it, they have a bank credit account, and it goes up and goes against our account. That's borrowed money. They pay interest on the money. Companies don't keep cash to pay all their bills. They do everything on credit, and they receive money from the customer and pays off that credit. That's just the way companies work. The #1 reason why companies go bankrupt in the United States is cash flow. And the other fact is all their bills are due, and they haven't got the money from the customer yet. So they have all the money, they just haven't received it yet. And what are we? I think we're net 60. In other words, we pay you 60 days after. When I started out, we used to be everyone companies were net 30. 30 days after we received your bill, we'll pay it. Now companies are 60 days. They're holding on to cash longer. Okay? Now companies going to 75, some are even 90 days. Toyota is like, we'll pay you 90 days after we receive a product. So if you're a small business, that hurts. Even a big business like this, okay, so the more you buy now, that's just the more money we're putting on a high credit card. Kind of like my wife buying all those big beans on a credit card. Okay, and I got to pay that interest, and I don't use them for 2 years. Okay, but I'm paying interest every month. Did she save me any money? No. That's the problem with inventory. Okay, so if you have excess raw materials, okay, one of the things we're really working on in the warehouses is to reduce how much stock material we stock in the warehouse. Why? We bought that stuff on credit, and it's just sitting there for years. Excess finished goods. Okay. Once again, it's kind of like the Mexican plant. We're building it to a warehouse, and it's going to sit for 2 weeks. Just a waste of money. So why? Well, guess what? We got to bring this stuff in because I know they're late on shipments. They're really bad. Our customers are really bad on bringing it to us. But just in case, I want to make sure so I don't cover my line. So rather than fix the problem, you just build up more inventory. So who's paying the bills? Not the vendor. We can't beat your time, but you can't keep it up. Okay, bulk discounts. That's my wife. Bulk discounts. Yay. Okay. Worked at a plant in Michigan, and we made cabinets, but we made cabinets for restaurants. So if you go to Taco Bell, Arby's, and you look in the back, you see all those stainless steel food preparation tables, the shelves on them. That's what we made. Okay. And so the last thing we did is we had plastic on the piece on top. And as that piece went in the truck, the last thing the shipping did was peel that plastic off. So when it got to the customer, it was just pristine and beautiful. Well, the purchasing department said, hey, we're going to buy this stuff without plastic on it because it's going to save us $100,000 a year. So we go to shipping, quality look at it, there'd be a big scratch on it because we moved around all the place. They okay, rework. So our rework lines were running 24/7, 3 shifts a day. I had to add 10 more people to the line to polish, buff all these scratches out. Okay, cost the company about $2 million a year for $100 cost savings. Right? How do you do? So don't use overproduction. Okay, ensure layout. If you can't fit any extra inventory, you can't have extra inventory. Okay? So here's motion. Okay, transportation is moving parts. What do you think motion is? If it's not moving parts, what's that? What's moving? What's in motion? You are.
The person,
Yeah.
how many steps they have to take to produce a part.
Okay, go back to that plant in Michigan again. Okay, one of the things we made was Arby's. Okay, look at Arby's. They're stainless steel tables. It's 12 gauge steel. It's 14 feet long. It was a huge 14-foot piece of continuous stainless steel that we would roll on top of these. And the way you made it was you had to put a bend, on the side. You had to actually bend on one side. Then you do bends on the 2 corner pieces and bend on the other big side. So we had big brake presses. And so I see these guys, and there's 4 guys picking this 14-foot long piece of stainless steel, and they start, and the plant's probably about from here to pod 4. And they're up here like this, and they're walking like all the way to pod 4, carrying this 14-foot piece of metal. Then wait about 2 minutes, and they're carrying it all the way back. What the hell are you guys doing? Is that, well, this thing is so long, the only way we can bend this big 14-foot long is that one big brake press is back there. But it's not, this isn't our department, so we have to use these, so we have to put a small brake here, carry it there, carry it back, and carry it back 4 times. So you had 4 guys carrying this thing, the entire length of the plant, carrying it back. Like, why? Because the machines weren't, I go, just put the machines next to each other. So we did that. We moved the machines next to each other. Our productivity got a lot higher, okay? Because that extra motion was not adding any value. Okay? But motion is not just walking. Motion is also, okay? If I'm working on this right here and I got to reach way over here to get this tool, way over there, Okay, one, that's bad on your back, ergonomically bad. Two, that doesn't have any value. If you take the standardized work class and show a video of assembly out here, and there's a guy, he's doing cabinets, he's stapling, he's gluing, he goes like this and he's moving. You know what? He never looks away. He never twists, turns. He doesn't ever have to look for it. Everything's right there. To me, that's awesome. Staple gun, glue gun, right here, and he never had to move his feet once. He never had to twist, turn, bend. Everything was, that's what you want. But instead, I walk in other departments and I see the people going, go to gathering. You know, we did a 5S on the gathering cells. I was watching those poor ladies, and they were having to run all over the place. And they had a U-shaped thing right here, and you had the tops and the sides. Well, they're oak, so an oak goes to oak, an oak doesn't go to maple. So wherever it was, so the sides are here and the tops are over there. Sides, tops, stick them in the cart. Because they had all the sides here, all the tops here, like all the common woods, organized by woods, instead of organized by pieces. So we did that, and then it was like, load. And ladies were like, oh, we've been saying that for years. But no one listens. Okay, we eliminated excess motion. So, poor workstation layout was an example of that. Disorganized tools, can't find it. If you see someone looking for something, although you aren't laid out real well, too much motion. How do you pop the 5S? 5S. You organize your work cell, you can find everything. You don't have to look for it. Okay. Anyone know what SMED is? It's not so much to apply here. Single minute exchange of dies. That is basically is you want to have all your changeovers from one product to the other in less than 10 minutes. So you want me in the single minutes dies. And so I used to work for a plant down in Owensboro, and we made plastic for batteries. So we had these big extruders, plastic extruders, and they're probably, 8-10 feet long, and they put the plastic in there and come out my spin sheet. We had to switch those out. Well, it took 4 hours to change from one product to the next. So I did a little SMED event and figured out what was going on, and found out that 3/4 of that time was waiting on a fork truck. And I said, why? And they go, well, because we only can use it with Big Joe over here. And Big Joe is used all over the plant, so we only can use it when it's free, and it's not very often. But why is Big Joe the only one? Are these dies that heavy? Oh no, they only weigh a couple hundred pounds. Any of our fork trucks can lift them. Well, why is Big Joe the only truck that can lift those? Because the fork truck tubes were so far apart that only Big Joe could spread that wide. I go, well, can't we just put tubes closer together? So for about $25 in metal, and a little bit of welding, we welded another fork tube on there so any fork truck in the plant. Cut out 75% of our time on die changes by adding a $20 fork tube. Just so we weren't waiting for a fork truck. So that was waiting, that was excess motion, is all other things. Okay? Excess processing. This is kind of like that. I talked about the cabinet where we had to do all the extra rework. We did extra processing that wasn't necessary. Okay? So what is this? So why don't you pay for it? Isn't it better? The more work you put into it, isn't it better? If I paint the backside of those cabinets, that's a better cabinet. Can I charge the customer more? Why not? You're not going to see it. And you pay for something you don't see. Okay. The painting areas won't be ever seen. Over sanding it, we sand. It's good enough the first time, but we just keep running through sandpaper to make it better. Tolerances are too tight. Okay. Let me give you an example. Okay. I'll work it for work. My store. Or automotive. Okay. This is a Nissan Maxima. This is the headliner of a Nissan Maxima. It sits on a Nissan Maxima. You put your hand up, and where it stops, that what you're feeling is a headliner. And what it is, this is the upside of it. What it is this is fiberglass, and then there's material that's heat pressed to it on the other side. And then you've got cutouts. So this right here is here's where your visors mount. Okay, your two visors. This right here is a console panel in the front where you turn your lights on and air conditioning, things like that. So that's all it is. This one has 2 notches. This is 1 notch. Because the Nissan Maxima, if it rains, they have a thing called rain sensor that it detects the rain on the windshield and turns on your windshield wipers automatically. Costs a couple $100 more. If you don't want to buy that couple $100 more, you can buy it without it. So it comes without rain sensor with it. So what they do is this is where the wire runs. And the wire runs from console here down to the stuff. Okay? Because right here is where the sensor is. So we had to buy an extra machine to put this extra notch in there. So we had 2 products that were exactly the same. They look the same, they fit the same, they both sit in the same vehicles. One's got 2 notches in the front, one's got 1. Okay. Do you know how many times they put a car in there and had the wrong one in there, they rejected that car, they fined us, automotive, they fine you when you make a mistake, you got to pay for it. How many times we had to ship them replacement parts? Because once you pull it out, it's damaged and big time money. So my thing was, why don't you put 2 notches on all of them? Why don't you just go to 1 part number? Because when I went down there to Smyrna, Tennessee, and I saw the production line, guess what? There's a plastic trim that goes over this, and you'll never see it. That's completely hidden. No one ever sees that. But we were paying tons of money and having all these quality problems because we're mixing up 1 notch versus 2 notches. Okay? So why don't we just put 2 notches on all of them? Well, you can't do that because if you switch the cables, they and you put it through the wrong hole, they'd be too short, they wouldn't fit. One big notch. So we got rid of 2 notches, we made 1 big notch. So it didn't matter, you couldn't mess it up, no matter how you did it. It always went from 2 part numbers to 1, and our #1 quality defect went away. Because we were doing something the customer did not care about, because they would never see it. But that's the way it was designed. And that was called our #1 quality defect, mixing up this with that. Okay? So, detailed quality standards, okay? Procedures that reflect the customer's expectations, that's customer's expectations. All right. Stretch real quick, we're going to change subject, and then we're going to put you guys to work. Okay, excess processing. What's excess processing? Oh, we talked about that, okay? Value, non-value added. What's value added?
What the customer's going to pay for.
Customer training. What's non-value added but required?
They won't pay for it, but you have to have it.
Non-value added, not required?
Waste.
All right, so we'll go over that now to the slide. Basically is, what the customer wants, when they want it, or they want to pay for it. That center area is what we're looking on. So think about this as a pizza shop. If you're going to buy pizza, what are you paying for?
Pizza.
Pizza and a box. That's pretty much it, right? Do you care that they have 3 ovens, just in case one breaks down, they have 2 backups? You're not going to pay more? No. Or that they have 5 people making these pizzas instead of the 2 that every other company does? You're going to pay more? No. Aren't you paying more because they have to, like you said, build it next door and drive it in a truck and drive it around the corner? Okay. Are you going to pay them to cook it? Yeah, I don't want a raw pizza. Okay, so that's probably required. Okay. Am I going to pay you to fold the box? Probably not, but do you have to fold the box to put the pizza in? Yeah, okay. That's probably, required. So think about new cabinets. Okay. Are you paid for stain? Yeah. Okay. Are you paid for someone to set their gun up, adjust it, get the flow rates going?
No.
If you don't do that, you can't paint it? So you got to do it, right? Okay? If I don't clean my tips of my guns, if I don't get the flow right, if I don't set it up like that, the customer ain't going to pay me, but you got to do it or you can't paint. Okay? But now I'm out of finish, and I'm like, oh shoot, where's that? Supervisor, needs some more. Okay? And he's looking around, where's it at, where's it at? And they got the wrong one, all of that stuff. That's all that isn't necessary. It's one of the things that you have to do. It's one of those complete wastes that just costs them money. All right? Going back, we're done with 8 wastes. Let's talk about overproduction. Why is overproduction the worst?
Because it has every one of them in it.
It hides them. Okay? Like in this case, overproduction will hide that only 5% is value added, and the rest of this is. Because guess what? If I hit my trucks every day, I'm out here at 8 hours every day. I'm out here at 8 hours every day. Okay? I'm not really caring about how wasteful I am. It never hurts me. I got overproduction. If I can pull stuff out of a warehouse and never miss a customer shipment, I never encourage you to get better because I got it hurt. That's just human nature. I'm good. The late orders, 0% late orders. Yeah, it cost me like $10,000 an order, but none of them were late. Okay, so talk about what is moving on? Okay, typically, here you do batch manufacturing. You build a bunch, change over, build some, change over, build some, change over, and so you have total value added and non-value added time. Okay. So then now we want to get better. So we take a little bit off the end. Okay. Lean manufacturing is we take our value added, non-value added, and get rid of all that non-value added, not essentials. Save money. All right. So here's another way of looking at it. Here's how much we sell our cabinets for. How much it costs to make it, here's our profit. In the old days, if we want to make more profit, if you need more profitable, you jack your price. We're profitable. And now your vendor would say, oh wait, we jack our prices too. So what do we say? Oh, we just jack our prices again. Right? That's what used to work. Prices used to always go up, 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 up. Here's what happens today. Hey, we need more of a profit, Ferdinand. What we do is we cut our costs. We get more efficient. Okay? So now we make more profits. But then a vendor increases their costs. So we can't jack our costs. Price. So what do? We just lose our profits. Because the customer may pay more. Competition from the Chinese is saying they're actually going to go down. Okay. So how do we get there? Eliminate waste. Okay. Let's talk about technology. Most organizations use the latest advances to spare themselves the painful commitment to basics. What does that mean? I'm about the newest and latest and greatest saw. I put a robot in here. I'm gonna throw technology at this problem because that makes it profitable. When the real problem is you have all this waste in the system. Okay? It'd be like Mercury Motors buying faster fork trucks. Hey, look at this. We reduced our move time by 20% by buying faster fork trucks. Now we killed a bunch of people because we're driving so fast. We're dropping parts all over the place. We're flinging them around all over the place. And the problem really wasn't that, but the greater new technology will cover up a lot of your sins. Americans are great at throwing technology to cover up the sins of we don't want to do the hard work. Let's buy something new. All right. So guys, we're breaking teams. So here's the deal. Who here works in the same department? Okay. Now group up with people in your same department.
How many people in the group?
You get 2 to 3 in a group. And what I want you to do is we're going to go for a Jimbo walk. And you don't have somebody to do Okay. What department are you in? Okay, she used to be here. You got fine. I got enough, I guess. Everyone got the one for your group? All right. What I want you to do, I want you to go to your work areas. And try not to go to your business unit. But don't go to the, if you can, don't go to the exact line you work on. Because you're going to see that stuff every day. You'll be doing that looking up seeing. So like, if you're in pod 1, go to pod 3 or something like that. And look through one of their, if you're working at walls, go to baseline. Okay? And just take about 20 minutes. Let's be back in here at 10 o'clock. Okay, 15-minute break. Come back, and what you do is go down this list. And these are all the 8 ways. Right? So I want you to come back and give me your top 3. So find as many as you can, but you really only have to talk about your biggest 3. So, I mean, you're like, if you find, motion was a minor one, record it, and then decide which of those three you think are the biggest hitters, and talk about those. Okay? So you guys know what to do? On the floor, take a look at these, and identify, and then try and think what caused that.
Fire department people had a long way to walk. In their defense. That's it.
Nice. So you got 5 minutes to look and 10 minutes, 20 minutes of walking.
Yeah. Yeah.
So then you have excess motion, right?
Yeah, that's right.
Motion is people and transportation is parts.
A little winded.
One minute we'll start with hour. So it's like the Lucille Ball video.
I love her. I do too. I love her.
We still watch those so long. And Andy Griffith.
Yeah, I love that. I could watch that over and over.
Yeah, it's amazing. You watch some of the old stuff and you realize how good it was back then.
Yeah, exactly. My son.
All right, let's get it for you. All right, let's start over here in this group right here. Let's give me your top three you found.
What defects, waiting, and overproduction.
So let's go through each one. What did you find in defects?
There was a lot of DMR.
Okay, guys.
Waiting,
A
definitely.
DMR, is a DMR a defect?
It was originally.
I mean, does the customer pay us? Hey, you DMR'd this part 10 times. The customer gonna pay us more?
No.
Okay, we have like 1,000 DMRs a day. That the monumental amount of money we spend on DMRs is incredible. We can maybe increase our productivity, say it much better if we just not make it right the first time.
Yeah,
That's a great.
come back and find it again. Yeah, you want to do those?
And then we also saw overproduction. We saw a lot of product on skids, carts, conveyors that was not moving. It was just,
This is.
yeah. And it seemed like they were producing more than they were ready for at the time.
So why do you think it was?
What the,
Why do you think their overproduction was there?
Their supplier gave them more.
They just ran everything they had and you know it wasn't needed? Okay.
they weren't ready for it.
Good.
We also saw a lot of waiting, like a guy waiting for like a changeover, and I don't know if it also goes in, you're just standing there, like,
Oh,
a lot of that, a lot of that, it seemed like they weren't utilizing their people. They had too many people doing one thing or the same thing.
yeah.
They weren't utilizing their people. We saw employee taking parts to stage when they weren't ready for them. They were just sitting there, and then the process of it just seemed to be the problem. And then it got moved like 2 more times,
Good one. All right.
and then there was a machine while we were there that fully, the machine went down too.
Were you surprised how much waste here was slot? You were? Good. Anything that?
No, I think you went over it all.
All right, so what do you guys find? Who are your top 3 wastes you got?
Defect,
Defects?
motion, and inventory.
Defects, motion, inventory. So what did you find for defects?
We're in the middle row in the flow racks. Every load that comes in, the top and bottom piece on that load gets thrown out. It's produced as a normal piece of material, so that's overproduction.
Wow.
But they have to band it, so it's required for safety purposes during, transport.
So we couldn't use a scrap piece in there and
We could, you would think.
that's a good one. You need to bring that one up. That's a real good one. That we intentionally scrap a perfectly good part, just abandon it. That's a good one.
Motion was over travel to retrieve the material. We're using 6 of those tank racks for people to pull out of. And if you look at it, all the empty space that's in those racks, it could probably be condensed down to 4. so that there's less walking.
Less walking.
Those people would be carrying a 96-inch lineal,
Now, these are both of them, all right.
which so it's not required, not like added. Inventory, there's material on hand that's got inventory tags on it from 2 years ago where we're not using it.
Wow.
A lot of cherry and just colors that aren't used so much anymore. But they're required for warranty purposes.
Oh, wow,
We
yeah.
have to keep everything for 5 years or whatever.
So, you guys surprised? You guys looked without seeing, or you guys actually started seeing some waste that you weren't kind of surprised you?
Well,
But you knew about it?
I see one of the parts of my area, so I see it. I don't know, between these two, probably.
I mean, I thought it was surprising that they're scrapping out the top and bottom of every single load.
Yeah, so how many pieces of load?
I mean, most of your wall pieces, anything under 20-inch piece, maybe 24.
So 24, so we're running about 4% scrap rate, just
Just to get it.
built into the process. Any customer paying for us for that? No. Whoops, all right, those are good ones. All right, let's team over here.
Ours was waiting, transportation, and motion. The waiting, the employees didn't have any work, so they were all standing around but it was due to the machine broke down up all the way to the front. We did the flat line.
So what, do you know why the machine was broken down?
Sandpaper glue.
Okay.
So
Machine downtime, we talked about that being a cause of waiting.
they have a lot of that on the flat line. A lot of the sandpaper busting. The transportation, we felt the A-frames, they have them sitting over. So they come off the line, they set them over here in one area. Then eventually they'll take them from that area and put them into the semi. And then from the semi, they'll go over to the warehouse, right? And then we put back in the semi and shipped out.
A lot of over transportation.
Yes. And being in the motion, I feel like the employees at the end of the flat line have a lot of walking, excessive walking,
Yeah.
because they have,
They have to take the frames from the lines to the specific carts, but it's like,
the specific
Oh,
carts are
wow.
like.
Yeah, there's like
all
20,
spread out.
30 carts out there.
Yeah.
You gotta find the right cart and wonder if, make that visual, make it easier.
And I don't think there's ever any specific, like, they used to have like pod 1, pod 2, pod 3. I don't know if there's any specific way they set them up anymore or not.
Okay.
They just pull them in whichever way they pull them in, I think.
All right. Good. Anything else for that? Anything else?
No, that was most of it.
All right, your top three over here.
All right, waiting, transport, and excess processing.
Okay.
So with the waiting, we had builders waiting on rails, and then sand and pin waiting on doors,
So how can you tell they're waiting?
because they didn't have anything
They're-
in hand. They were, yeah.
Watch the hands.
Watching the other.
Watch the hands. It tells you whether someone's waiting or not. Very good.
But they also only had like one stall operator, and then one person on the Kuiper, but then they had two builders, and then 2 people sanding. So that kind of
It wasn't work balanced?
no,
Okay.
that slowed it down. But there was also a VBS observation going on too. So I don't know if that would affect
Not darn
anything. But transportation from building conveyor to sand room to staging conveyor. So it goes from one conveyor to another conveyor, and then finally goes to sanding.
So how does it move from one, how does it actually get physically from one conveyor to the next?
Carts.
Carts.
One
So you see,
person.
so it comes off the conveyor, you load it on a cart, you move the cart over, and you set it back on another conveyor.
And then another person.
There's
Yeah.
another conveyor. So that's, man, I'm a customer, I'm gonna pay extra for that cabinet, right?
Excess processing, sanding the entire surface of a pre-sanded rail, going around.
Oh, wow.
Yeah.
Okay.
I guess they've been experiencing some roughness, but even then it just became a habit of just going all the way around it instead of.
We had a problem once, a long time ago. It may have gone away, but we just keep doing it over and over.
Yeah.
Yeah. Okay, that's good. Another good one. But these are all each one. I think everyone got some ones we could do a Kaizen on to a project. some improvements in here.
He was with
Was
us.
that, anything else you want to add? Were you guys surprised, or was it like, oh yeah, we knew this?
No,
Anything surprise you?
yeah,
I think the transportation was pretty surprising.
yeah. Never really thought about how many conveyors it has to go through just to get to its final destination. Instead of just stacking it right onto a cart and taking it straight to them.
Yeah.
From here to here to here.
Because I want you to think about downtime. Think about go through your list. Which is the hardest you think to observe? If you guys just walk the plant, just 20 minutes walking the plant, what do you think is the hardest of those 8 ways to actually see?
Not utilizing people.
Not utilizing employees' knowledge. Yeah. Okay, you get a red star for that one. Good job.
You even said that.
All right. So how, knowing that one, how many of you, when you went to your area to look at it, went to the operator and said, what's messed up with your area? You guys did?
I did ask a lot of questions. She immediately thought she was in
Well, she raised her hand first, so she gets the red star for that one.
She thought she was in trouble because I was asking her questions.
Because you know why? Who knows that line better than the person who runs it? Ask the person who, hey, what's good with your area? This. Those come with a big list of what's wrong and where the waste is. Because they deal with it every day. So, that's kind of the trick question on this. When you go out there and you check the lines, talk to the people. Find out what they think is wrong. And makes your job a lot easier because they know it and they deal with it every day. Okay? But then always be the outside eyes who have fresh eyes because they may not see it every day. What do you guys think? You guys thinking you could get to the root cause of this? Why we have these and help the team get rid of it? All right. Any questions about 8 ways before we move on? You got this? All right. What we're talking about now is finding the root cause. Okay, and plan to check actions is the planning part. Okay, we're going to find the root cause of all these wastes. Okay, and so I was walking to work the other day, and a tree in my front yard had overgrown and had a branch and it's hanging over my sidewalk. So I walked through the tree, and this branch cut my face. I'm like, oh my God, I'm bleeding. So I go to the house, and I look under my cabinet, and I look around, and I can't find a Band-Aid. So I go room to room, cabinet, taking about 20 minutes. Finally, I find some Band-Aids. I put a Band-Aid. I go there. I'm late to work. So, I'm a good leading manufacturing guy. I know my problem is I haven't 5S my house. So I have a 5S event in my bathroom, and I've organized everything. I've labeled all my drawers so I can now I can find the Band-Aids better. So I walk out the next day. I cut my face on a darn branch again, but this time I'm 5S. So I run back to my cabinet, I get that Band-Aid, I put it on. I'm only 5 minutes late to work now. I've improved my process. Okay? But it's still not fast enough. So I reorganize and relay out my line, do the work balance, and I set a first aid kit outside on my porch. So I walk out there Wednesday, and I walk by, I cut my face again, but this time I'm quicker. The first aid kit's right there. I put the Band-Aid on. Okay? And I get to work, I'm only 1 minute late now. Okay, but I'm an American, and I understand the way to solve problems is with technology, right? So what I do is I spend $10,000. I get one of these collaborative robots, and I put it down the sidewalk. And I program it, and I put a Band-Aid, an automatic Band-Aid putter on there. So I walk out there, I cut my face, I'm bleeding, then the robot slaps the Band-Aid on my face, and I get to work on time. And it only cost me $10,000.
You didn't get rid of your tree.
Did I ever identify the root cause of the problem?
The tree.
What was the root cause of that problem?
Your tree.
If I trimmed the branch, I wouldn't have needed all that stuff, wouldn't have needed to have done all the other things. So a lot of times we attack what is not the root cause of the problem. And we'll throw time, and Kaizens, and technology. We love throwing technology at the problem without identifying root cause of the tree. So, what were the observed symptoms? What did I say? No, let me know I had a problem.
The scratch.
On a bloody face, right? Okay. So my facts and gathering analysis, but I never really identified what was the direct cause. What was the direct cause of that cut? Not being able to find the Band-Aids?
The tree.
Taking too long to put Band-Aids on? Okay. So I did a little, if I go down there, I get to the root cause. That's what we're going to try and do. Okay. So one way to do this is ask 5 whys. Okay? I always love this cartoon. You only get 3 whys, and what the hell? That usually happens when you get your 5 whys, you get 3 whys, and you're like, what the? All right. It's a drill down problem solving technique to get to the root cause. Okay? This is how we identify ideas for improvement. Okay? So first of all, you state what the original problem statement is. Original problem statement is, I'm late to work because I cut my face. Right? So the question is,
Why did you cut your face?
why did I cut my face?
The tree branch was in your way.
Tree branch was in the way. Why was the tree branch in the way?
Overgrown.
Okay? So now, why overgrown? Because we're watering, you can go down here, and now I'm not focused on the Band-Aid, which is the symptom. I'm focused on the root cause, okay? So here's a sheet. There's actually a form we find online where you have, here's the problem, question, answer, question, answer, question, answer, question, answer, 5 root cause, okay? And you come up with the root cause, and then you can come up with countermeasure. Countermeasure in this case, trim the tree. Okay? So here's one from a manufacturing example. You have the problem statement. The base assembly line shut down. So what that's the problem. First question to ask is,
Why did it shut down?
you guys are all good. They're all good. Why did the base assembly line shut down? Okay? Well, it shut down because the carton packer shut the line off.
Why didn't the carton packer shut the line
You guys are good. Why did the carton packer shut the line off? Well, he did it because he couldn't find the carton.
Why did you find the carton?
Man, you guys are great. Great audience. Okay? Well, he couldn't find the carton because it wasn't in the cart. Because the carton was not pulled by the carton puller.
Why didn't you pull it?
The carton was not on the list to pull. Oh, wait, we're 5 whys. We're done, right? Problem solved. We got 3 causes. We're done. We got 5.
No. Why wasn't it on the list?
Well, we only have 2 5.
We better keep doing it.
Oh, okay. Sometimes you can get there in 3. Like 3 times we figured out the branch need to be trimmed, okay? But sometimes, 5 is not the magic number. You do it till you get 5, because usually by 5 you can solve it. But you can go as many as you need until you get to that root cause. If you do it 3, you do it 3. You do it 7, you do it 7. Okay? 5 is just what they call it. Okay? So, why was the carton not on the pull list? Because the bill of material is not correct. Okay? The bill of material is not correct. Can we get to the root cause? Bill of material is wrong. So we put the wrong card in there. So, what's our improvement? Correct the bill of materials. Next time it comes through, the right card will be there. And all those other steps will go out of the way. Okay? Because the real problem with the paperwork was wrong. Or I can just write up the carton puller. That's what we have to do things. Okay? So, it doesn't have to be 5. It might be 10. Okay? If you want to make sure you get it right, trace it backwards. Okay? The tree overgrew the path, therefore it cut my face, therefore I needed a Band-Aid, which maybe that could work. Okay? Not, I couldn't find the Band-Aid because my room was disorganized. Okay? So in this case, the bill of material was not correct. Therefore, the carton was not on the list. Therefore, it was not pulled. Therefore, the carton was on the cart. Therefore, couldn't find the carton. Therefore, they shut the line off. Therefore, it's in the line shut. Okay. I know I'm going right. If you go one way and you turn around and go back the other way, you know you got the true root cause. Okay. And you're not chasing Band-Aids. Because that Band-Aid isn't going to prevent you from getting scratched the next day. Okay. So use Y on the way down, therefore on the way up. Okay. Another way to do it is fishbone diagrams, or Ishikawa. Japanese guy invented them, called Ishikawa. They're called fishbones because it looks like a fish. Okay. It's a brainstorming process. Okay. Looks like this. Here's your problem over here. These are the possible causes. And before the politically correct days, there were the 6 M's: measurements, materials, manpower, man, Mother Nature, methods, machines. So you'll find some of them, there's the 6 M's, which is better than 4 M's, a P, and an E. But it's still basically the same thing, okay? So in this case, the problem is with handling damage, okay? So this could be caused by, incorrect labels, or the materials could be wrong, or someone could make a mistake. He wasn't trained, he wasn't strong enough. The cabinet was, was too heavy for him. Could have been part of the environment, dust, lighting. Could have been the methods, his lifting techniques, or it could have been the machine. Okay, but not all of these are going to be the possible causes. So what you do is you list every possible causes, no matter how remote. Okay, this right here would be the input categories, your successes, your problem, your inputs. Okay, what you do is you write the problem, right, get those, get the steps. Okay, and then you go through and you say, okay, which ones? Okay, that's not it. Okay, there might have been, hey, the lighting, maybe the lighting wasn't bright enough. You walk out there and the lighting's fine. Okay, cross the lighting out. That wasn't it. Okay, so now you start saying, okay, these are all the possible ones. These are the ones that can't be. These are the ones that could be. Then you investigate each of those to see which one actually caused the problem. Which one caused that waste, caused that defect. Okay. You can use fish bones, you can use 5 whys, or you can actually use them together. Okay. Because here we go. Let's do our 5 whys here. We have 20 minutes downtime on the Pac-9 2 to the label printer, not printing. First question we asked?
Why was it on the printer, not printing?
Okay. The nozzle was clogged with dry ink.
Why was it clogged?
I don't know. I'm stopped. And so now we got to figure out what are all the possible causes. Okay. So now we go into our fishbone and say, well, maybe the operator left the printer in over the weekend in the dry. Or maybe, over here method, maybe the SOS didn't require purging when you're done with it at the end of the shift. Or maybe we used the wrong ink. Maybe the machine was broken. Maybe we had the wrong inkjet on it, or maybe the electrical impulse was too low. Okay. Now we'll go through here and see which ones are likely, which ones are not likely. Okay. Oh, sorry, another answer. Ink could be plugging, could be high humidity in here. Cause ink to clog. Okay. Those are kind of doubtful. It's the same nozzle we used yesterday. It worked yesterday. Electricity hasn't changed. Humidity hasn't changed. It's the same ink we use every time. Okay. But hey, it doesn't call out purging in the SOS. And maybe the ink was left over over the weekends. Maybe it's one of those two. But you know what? We checked the SOS and hey, it is in there. So why was it left over the weekend? Worker didn't print it, didn't purge it. Why? Well, worker didn't know what was in the SOS. Okay? So why? And the training matrix doesn't say showing the guy how to read the SOS and how to do it. So we identify root causes. We got an untrained operator who left the ink in over the weekend, and that did it. That's how we, when we hit the I don't know, then you do your fishbone and figure out. See how these two, you can put these two together? All right. Here's the different branches. Talk about those measurements. They haven't been collected. Okay. Maybe you're measuring it wrong. Maybe the guy didn't have a tape measure, and he's getting the wrong pieces. Okay. Maybe the raw materials are wrong. Maybe the person screwed up. Okay. You saw earlier. You saw those headlines we made for Nissan. Okay. It's fiberglass and cloth. And they put them in a press. And they put heat. They bake them together. Well, we're getting to the customer, and they're unpeeling. So we did our 5Y analysis, went through everything, and went to Mother Nature, and said, well, maybe if it's too cold, they wouldn't stick together if the press was too cold. So we went through there, we did our analysis, we did all our data analysis, and we corrected it all up, and we found out that every single part that was separated was a Tuesday at 10 o'clock, manufacturing time. Tuesday at 10 o'clock, those parts were, every part made from like 10 to 10:07 went bad. So what I do? Went up there at 10 o'clock, and I watched. And the FedEx guy came, and they opened up the overhead door, and the cold wind came in and cooled the die. About 7 minutes later, he closed the door, and the machine started running good. Mother Nature was the problem. Because when the UPS guy came, he opened the overhead door. And we only ran that line on Tuesdays. Or we only ran that product on Tuesdays. And from 10 o'clock to 7, when he came in every day, threw in the parts. Okay. When we did our 5Y, our fish film, Mother Nature was the problem. Okay. We just put a curtain there. Problem. Right. What is it? The procedure to do it? The method, or the machine itself solving the problem? Okay. So, guys, I threw a bunch of stuff at you. We talked about the 8 ways. You guys walked the 8 ways. You guys identified the 8 ways. Okay. We talked about how to identify the root causes of those 8 ways. So, how do you apply these concepts to your everyday work?
When I go out, I'll be looking for a lot of these things, and you can also show others what you see and explain to them.
Okay, so how do you keep others from looking without seeing? How do you prevent yourself and others from looking without seeing?
You can try talking to them and kind of bring it up to them, and maybe they'll start paying more attention to it.
You know what? They probably don't see it. They probably don't notice it. Maybe point it out to them and say, you had some good ones there. Hey, or this one. We're over sanding a part that's sanded. What? You know, why are we doing that? Oh, I don't know. We've always done that. Can you use any of these things outside of work? Yeah. Where? I'm a lean manufacturing kind of like jerk, and my wife, when she took our clothes, she always put them in the wrong drawers. I open my sock drawers, and my underwear would be there. I can't find my socks. And go over here, they're in the t-shirt drawers. So I took the label I bring from work, and I labeled white socks, black socks, t-shirts, underwear, and I labeled my things. It was so much more efficient. For marital harmony, it was not a good thing to do. If my wife did not appreciate my efforts at lean manufacturing, I thought it was great. She did not like labels on my drawers. But okay, that's fine. I'll just tell you a real quick story is, if this was a counter, church, and behind the counter was the coffee and all the kitchen, things like that. So when everyone came to get coffee, they came by and they'd get their coffee and they'd get their donuts and their snacks and they'd walk off. Well, I'm being a gentleman. I don't get my coffee until everyone else is done. So church is over, we have coffee hour. So I get in line. Anytime I get in line, I pull my stopwatch because I don't need manufacturing back. But I time myself. True story. I time myself. The time I got in line, the time the first person got coffee until I got coffee as the last person was 20 minutes. And what's the purpose of coffee hour? It's to socialize. The purpose of coffee hour is not to stand in line. Okay? So what I do like the time motion study and things like this, and I did is took a table, put it in the middle of the room. And I put coffee on one side, juice on the other, because the old people took their coffee one time. The young kids would just get the juices and they go fast. Okay, but then, so they're interrupted. So I had the coffee and spoon for the older people here, the younger stuff were there, and if you just wanted like dessert or something like that, you could go there. Got 2 lines, and I did 2 process flows. Went to the next Sunday, first person got in line, saw my stopwatch, got my coffee, 5 minutes. And the priest was actually against it. So he goes, why are we doing this? This is harder for people who are making the coffee. They have farther to walk. Like, who's your customer? The 2 people volunteers in the kitchen, or 120 people after church who wanting coffee. You can use these things anywhere. Okay? I had a waste of waiting, motion, and all that stuff like that. So I got rid of them. So, guys, you can use all these applications at home, or at church, or your baseball, or Boy Scouts, wherever it's like that. Okay? This isn't just for work. I want you to use it at work because that saves the company money. All right. So, guys, you have a task. You have to, in your team as individuals, preferably as a team. If you do it as an individual, if you can't get a team together, I want you to identify wasting areas. You can use one of the wastes you identified today. These are all good wastes. Okay? Just pick one. Okay? I want you to do a fishbone, or 5Y, or a combination, and figure out what's the root cause of that waste. Okay? It shouldn't take you that long. Okay? Come up with some suggested actions to prevent or eliminate that waste. Okay? So we have the problem, the 5 Ys or the fishbone, root cause, countermeasure. I want you to schedule a report out. This can be one-on-one, or you can do it formally in here, or you can do however you do it with either your manager, or your superintendent, and me. Okay. You just send me a meeting request, and I'll show up there, or Jordan, or both of us, and anyone else who want to get involved, and just say, here's what I found. Here's how I'm putting this 8 wastes and 5 Ys in packets. That challenge you guys can do? Real quickly, guys, go to the MBCI homepage, mybci.com. Site location is Ferdinand. Okay? First of all, click on the training calendar for all your future classes. Here are your classes. If you don't have a register form, you click on the class. You click on the class, a hyperlink will open up. If you hyperlink click on the hyperlink, that'll get you to class registration. Okay? You can register for future classes. Okay? Same thing, go down here to the training calendar, click on the continuous improvement. Okay? If you go into classes, you'll see the 8 waste to 5 Y class or the 8 waste class. All these forms will be in there for the fishbone and the other couple. That's how you get to them. Okay? So once again, you go to the home page, site location is Ferdinand. Little green arrow, click on it. I'll bring you to the classes and all this course material, including this whole presentation. So if you forget, this whole presentation will be in there. Jordan will be good. He'll edit that video and help the video of today's class put in there. Okay, I'll be under classes. So in this case, 8 wastes. Okay. Now I want to have you look down the bottom. Down here's transcript generator. Okay. You click on that. The drop-down box, drop-down menu. Okay, find your name. Your name will be in there. You click on it, and that'll print out, or that'll pull up your official training transcript. Okay. So if you ever have to do a job interview for another job in the company or something like that, but you want to do your yearly review with your boss, you can print out your transcripts and say, this is the classes I attend. Why do I say this? Guys, if you want credit for this class, you got to do your project. That's how I control you guys, okay? You want that on your transcripts. Do your project, find one of your 8 wastes, do your 5 Ys or your fishbone, come up with proposed countermeasures, talk to your boss, invite me, I'll give you full credit for this class and the project. And I'll show up on your transcripts and they'll be heroes in my book. Any questions? I'll make sure all these fishbones, the 8 wastes or the 5 Ys, they'll all be in that class as well.
So this, it doesn't have like a time frame on it?
Whenever you want it on your transcript.
Gotcha.
If you don't want to graduate, you don't graduate. It's up to you guys. All I need.
They can come all the way here not to graduate.
Exactly. You didn't listen to me talk for 2.5 hours. You didn't watch funny Lucille Ball videos in order, not to graduate. Okay, any other questions? All right, it was a great class. Thank you, guys.
So how does it do this for summer?